Hello, I'm Bradley Momberger, a developer with Bitovi, and I wanted to do a short video to introduce the rest of the world to some slick features that I discovered recently as part of the StealJS dependency manager. Specifically, it's how you can actually manage web workers and do async code, but still keep much of the same simplicity, and especially as relates to module loading, as you get in your main application. Um, so let's do a little bit of background. When you run JavaScript in the browser, it runs on the same thread as painting the user interface. So the DOM updates will be blocked so long as you have a long-running JavaScript task running in your main thread. And in addition to not being able to paint anything, you're not able to handle clicks or hover events or even scroll the window. Any long-running script blocks the thread and makes the UI unresponsive until it's finished. So we have a few solutions as web developers to mitigate this. Generally, they involve things like breaking up the tasks into shorter segments. So you can run like a little bit of a task by using, say, like a promise chain, a bunch of set timeout calls, or the newer request animation frame, which will tend to run asynchronous code as fast as it can, while still actually letting the rest of the things that need the thread run properly. You can also use web workers, which are workers that are spawned by a particular window and will be disposed of when the window is, or shared workers, which actually belong to a domain and not a particular window and stay resident in the browser. So we're going to talk about web workers here, and we won't worry about shared workers. They do have their uses, but they're sort of outside the scope of what we're talking about today. There was also, for a very short time recently, a proposal by WebKit to actually put real threads into browser scripting using a particular API. That proposal, I mean, it was definitely future looking, and it seems to have gone dormant. So we won't be covering any of that in our async solution. We will be talking a bit about how you work with a web worker. So as a motivating example, we can talk about the n queens problem. The queens problem, where you take a chessboard of a particular size and put a number of queens on it and see how many different ways you can actually put the queens on the board so that none of them threaten other ones. It's a exponential time growth problem. It's got a very large search space. So it's actually really quick to run if you're solving for like a 4x4 board. It's still pretty quick on this particular computer up to like 11. Once you get to like 13 queens, we're going to see quite a bit of slowdown in how long it takes to actually run that. So you could run that in thread and just block everything for a while until everything's done. You could use the set timeout version where you yield every time you actually solve for a particular number of queens and then repeat for another one. You can also do like promise chaining, and it's pretty much functionally the same as doing a set timeout or request animation frame version. And then in the particular case of web workers, what you actually do is you load a script in a separate thread, tell it to solve, and then actually send information back as you get solutions. So the reason why this is cool is because the web worker is not going to block anything, and it's going to give you information back periodically that you can just paint into the thread, and it doesn't have to wait for the worker to stop running to get its partial information. So that's awesome. But the problem is that when you actually try to work with a module loader or a dependency manager, you run into problems because you initialize a worker by passing a particular script file, which is relative to your document root. The workers, they run in their own context and they don't share anything with the main browser thread. So in your main thread, you're going to have your window object, your regular object constructors, and knowledge of the DOM, an element interface, and that sort of thing. That's all missing in workers, and they don't share any objects. So with some exceptions, all you can really send is like primitive data and certain boxed up byte streams. And this can, of course, cause problems because without any knowledge about how your module loader has configured your system, you're not going to be able to do import script calls properly, for example. An import script, which is essentially like the worker replacement for the script tag, since there's no such concept of a tag when you're working in the worker thread. You have this import script function that can load scripts, but it's not going to really be able to work with what the module loader already knows about your system. So Steel, it has pretty creatively fixed some of these problems. So the way that Steel actually works is that when you want to spawn a worker and have Steel manage it, you let StealJS be your main script for the module loader, and then you can pass it a main to run as a module. So you can use ES6 module syntax that Steel supports, or even CommonJS if you want to do that. You can use all of the same script resolution, including like tilde for the project root. You can go directly into different NPM packages you have loaded in your tree, and also production builds are possible. We'll talk about that in just a second here. But here's an example of how you might show that. So this is actually taken directly from the can connect tests. So you spawn a worker and you pass the system.steal URL plus a little query string that actually provides what the main is, and that's enough to actually get the worker going with everything that StealJS would also know about your module paths. So that's cool, but to work with it, there's a couple caveats we have to cover. So for one thing, if you actually just started your worker module directly using a new worker and passing like your script as the worker script, it would run sort of synchronously. So as soon as new worker returned into the browser thread, it would actually have the worker script ready, and it would be ready to receive messages right off the bat. So Steel does some usually transformations, like it will turn ES6 into ES5. It will actually resolve module paths, and so this is happening asynchronously. So it has to wait a little bit, or like your browser thread is going to have to wait until your module scripts are processed and ready and run. And if you try to post messages immediately after spawning the worker, they'll probably be missed. So one thing you have to do when you are using StealJS with web workers is just post an initial message from the worker back to the window that says it's ready. And it's easy to catch. You just listen for like a type of ready and send it when your script is done running, and it's all set. The other thing is when you're talking about doing production builds, which is another major feature of StealJS, you don't want to try loading the entire script bundle, because it's going to start loading things that probably know about the DOM or expect things like the HTML element constructor to exist. You want to avoid that, and you don't really want to load the entire script bundle anyway, because that will be very slow. So Steel has a particular feature for building production script bundles called multi-main. And multi-main is very important for doing this. So the idea is you'd have like a main for your regular application. Then you also have a separate main for your worker. And then when the worker starts, it will actually just load the script that's necessary for running itself. And that will be separate from the rest of the application. So let's go ahead and do an example. I've prepared a little bit of HTML and some script to go with this. So we'll jump over to my Sublime Text Editor here. So pretty much here we have just like a basic nqueens implementation that is going to look at the queens problem from 4 to 11. This is using the 8queen package, which is available via npm. It's got a printer module that actually is going to print out with like some pre-formatted text. This is also adapted from the tests on 8queen. So what we're going to see when we run this in the browser is this will run pretty quickly, because the queens problem is easy to solve with a modern computer for these sizes. And we'll see all of the solutions output as individual boards. So let me jump over to the browser here. You can actually see it ran already, but I'll do it again just to show that this runs fairly quickly. So once we actually get the previous stuff cleared out, there. So that was a fairly fast run. It only took a few seconds, and everything was essentially done by the end. But you notice what's interesting about this, and this is something that I touched on earlier. We tried to actually append this output for every iteration rather than doing them all and waiting. But this whole block was rendered on the screen as one. And the reason for that is, of course, because we did this all synchronously. We calculated the solutions to queens and then got markup together and put it onto the DOM. But it had to wait for the thread to release before it could actually be painted into the screen. This becomes important if we did something like, say, queens for the 12 and 13 square board case. Because if you want to do on a modern MacBook Pro, like the end queens in 13 by 13, it's still going to take probably like 15 seconds to work out. So I want to show you, it's loaded, it's running, but we are definitely waiting a while for any sort of output to happen. And about 10 seconds have elapsed. 4, and we should get output just about now. Of course, I hadn't considered the computational overhead of also doing screen capture during this time, so it may be defying my expectations a little bit here. Right. All right, well, let's come back to that in a moment. We can start actually talking a little bit about how to do this asynchronously. So obviously this is, just a simple thing where it's going over a loop. What I'd like to do instead is maybe take this whole idea. And we finally got some output there in the back. What I'd like to do is actually move this over to a worker. So if we had a worker script, okay, so this is an example of what we like to do. We still import the queen solving function from 8queen in the worker. What we have here is, instead of just doing the loop right now, we'll actually take messages from the window thread. So this message will allow us to run queen with a particular board size. All right, and when it's done, it will actually output back using the post message interface. And like I covered before, whenever this is ready to actually run, when the worker script has been Babel transformed and executed and everything, it will post a ready message back. So we can change then the regular index to this other version with a worker. Now we still, as you can see, have the same loop, and it's doing 4 through 13 over all of that. But instead of actually doing the queen's derivation directly, it's posting that message over to the worker thread to say, please do this for me while I'm working on other things. So you can see that the worker is being built with system.stl URL, like we talked about. The main is just worker, like we have at the root directory here. And you can see that that loop starts happening on ready. And then we'll go back and look at this just for a brief moment. You can see that actually when each of these steps is done on the worker side, it's going to post a message with the output event type back. We can see in the index with worker side, we're actually looking for messages where the event is ready. Well, we have the ready. And then also we have this for output. So when we get output back from the worker, which happens every iteration, we'll actually append that to the browser window. And what we'll see now, if I take my index.html and turn the main here into index with worker, there we go. All right, I'm going to save that, and now we're going to go back over to the browser window, and we're going to see how this works differently when you offload your long-running computation to an asynchronous context. Once again, I'm not going to guarantee that this runs quickly, but what's cool about this is we'll actually see some of the early output quickly for like 4, 5, 6, 7, 8. There you go. And then as other things come in, 9 comes in, 10 comes in, 11 comes in, and now it starts getting to run slowly. But the partial output from running the loop is coming in as it's being computed at every step. And the cool thing is now there's no problem with me scrolling the browser. I can actually see the solutions for 4 through 12, even though 13 is still running in a worker thread somewhere. It will eventually finish, and we'll get all the messages back. But this is definitely very cool that, like, you know, I have no problem with like interacting with the browser window at this time. Some amount of stuff notwithstanding. I do still seem to have a little bit of problem like highlighting anything. That could have definitely something to do with like the way that my preformatted text is done or something. But this is still a much better UX than waiting for all 13 of these steps to show up. And there's the last one too. So that's essentially the way to get all of this working in development mode. You can actually see now that once the 13th one is in, it's not doing so much computing. I can actually start grabbing this again. It seems like maybe the size of the window here, because it is like a lot of just like long running text, may be a little bit slower to highlight. You know, for like a much more normal sized application, you probably have better results. So let's talk a little bit about doing production builds, right? So Steel has a production build generator. It will minify your script, turn it into single bundle files, also do the same thing for your assets. And a simple build script here, we're doing like the very bare bones minimum of building here. We build a main, 2 different mains, one with the index with worker. So that's this main script bundle that we've already been using in the in index.html, and then another one just for the worker itself. And when I build this, you'll actually see this. So I'll just get this started right now. And I'll skip over to terminal, and we'll just do node build. Okay, so there's our 2 mains, but they've done the opening of those. They've gone. Steel has actually gone through and looked at all the dependencies, understood what it needs to load to script, and now it's going to make transpiled versions with Babel and minified script bundles. And in a moment, it will spit out some output that shows me that it has done all of the disk bundling. All right, and so now we have a bundle for index with worker with a couple things on it, and then we also have the worker bundle. You can actually see that that's involving the 8 queen package, so that's nice and descriptive of what's going on here. So we'll skip back here, and I'm going to move over to the production.html because Steel has 2 modes. It has a development mode and a production mode. So the production mode is actually expecting to see bundle files in the dist folder, whereas the development one is actually building off of what's in package.json, and it looks for like first the main script as a separate file. All right, so we'll actually see this run the same way. It might even be a little bit faster because we've obviously done some minification and such. Oh, also I forgot to update the CSS in production.html, so there's a little bit of line height difference here. You can see that essentially, the same thing has already happened. We've gotten 4 through 12 done and still scrollable, still actually painting correctly. But I'll also just show you a little bit of of slickness here that instead of having like a bunch of script files here, we actually do have just the index with worker bundle. And if you look at this, this is actually the source for the worker, and Steel Production is working off of that, and there's a bundle for worker.js as well. So that's pretty much it. That is building with StealJS to use web workers for asynchronous execution of anything you need. You can easily with Steel actually use the same sort of module pattern that you would for your normal in-browser or in-browser window scripts. You can build them for production as you need to, and everything essentially just works as long as you remember the three things you need to do. And those are: send a ready message back from the worker and listen for it, build with multi-main, and what was that third one? I guess there were only two. I always think that there are three, but I think that, oh, of course. The third thing is, of course, use Steel.js as your worker main. And that's it. Thanks for tuning in. Thanks for listening. You can find more about StealJS at stealjs.com. And 8 Queens, if you want to do your own performance evaluation, is available on NPM. This is Bradley Momberger once again, and thank you for watching.